Good afternoon, and thank you for joining us today. My name is Andrea Watson, and I'm Tualatin Valley Water District's Communications and Public Affairs Supervisor. And I wanted to say that today will be the last edition for Talking Water in 2021. We will pick the series back up in some form in 2022, but we're taking a break for the holidays. This topic was incredibly popular, so we appreciate you taking time out of your day to join us. And next slide, please. We wanted to remind the audience that Tualatin Valley Water District is a government agency, and we do operate in a discrimination-free environment. So just keep that in mind as you type in your questions. The way our tool works, there's a little thought bubble with a question mark. If you're joining us on a computer or app, you can access that and type in your questions. We have staff who read through the questions and publish those, so please give us a few minutes. You don't need to type it in there multiple times. It does take us a while, especially as questions tend to come in big batches, but we will handle that process for you, and then we'll publish those out. If there's anything in there that profanity or anything like that, we aren't able to publish those. So we just ask you to keep that in mind. Also, as a reminder, we do record these sessions for viewing for the audience at a later date. So that's also just a letting you know that your questions are being recorded. And if we go to the next slide, it's my pleasure today to let you know we're going to have a short presentation on the topic of preparing your irrigation system for winter weather. Today's event is going to be hosted by Carrie Pack. She's a professional engineer. She is the district's chief engineer, and she has held that role here at TVWD since February of 2016. Carrie also is the district's first female chief engineer. She leads and manages a team of water professionals who have responsibility for the core mission to deliver clean and great tasting water to your home and business. Her team does that 365 days a year, 24 hours a day, and they do a great job. She has over 30 years of engineering experience in the stormwater, wastewater, and water resources engineering. The team that she manages comprises almost half of the entire staff that work at Tualatin Valley Water District. And more importantly, she'll tell you she's the mother of 4 wonderful children. In her free time, she enjoys traveling with her family, where she tortures them by stopping for pictures of manhole covers, valve covers, fire hydrants, and other interesting water infrastructure. So you can email her. Her email is carrie.pack@tvwd.org. And she's going to be the host today. And then we'll have the presentation by Steve Carper, who's our conservation tech, and Cal, who is our water quality. I'll let you tell it when you hand it over. Apologize for not getting the title, but Carrie, will you take it away?
Thank you, Andrea. Again, welcome everyone. Very happy to have you join us. I'm just going to do a quick introduction to your main speaker today, who is Steve Carper. Steve joined TVWD in 2006, so a while back. He has served as a conservation technician focusing on coordination of TVWD's conservation programs. Steve's professional background includes over 25 years of Willamette Valley landscape industry with experience in construction, irrigation, and maintenance. He served 2 terms on the Oregon State Landscape Board Contractors Board and is a certified landscape irrigation auditor. Outside of work, Steve enjoys brewing beer semi-professionally and at home. He and his wife, also Debbie, they live in Beaverton, and they're proud parent of a very young son whose name is Harrison. And we can't wait for COVID to be over so he can bring baby into the office for me to hold, because any of you that know me, I love babies more than anything else in the world. So with that, I will hand it over to Steve. Steve, take it away.
Thank you, Carrie. Hopefully everybody can hear me. It looks like I was able to unmute. Really happy to be here today. I'm glad we've got a good attendance, and I'm glad Cal is able to join us with his expertise as well. and we're going to go ahead and jump right into our presentation. I can get this to advance. So what we're talking about today is how you can winterize your irrigation system at the end of the regular season. To minimize the risk of freeze damage, it's important that you take a few steps to protect your system from damage over the winter months. And if you see the image in the main slide here, this is the situation that we're trying to avoid. After you turn your system off, some water remains in the pipe during the winter months, can freeze and expand, and can actually crack the PVC piping that makes up the main and lateral lines of your system. And water in the backflow assembly can actually expand and damage those brass components that may appear a little bit more durable, but they're actually quite susceptible to freeze damage if you don't take some action to try and prevent that. Now, fortunately, in our area, the frost level rarely extends to the depth of the lateral piping, and therefore today we're going to talk about the manual approach to draining and winterizing our irrigation system. And it's important to keep in mind that every irrigation system is unique. They're kind of like they're like fingerprints, and that no two are alike that I've ever encountered. And you might not actually have all of the different components that we are going to address today in our presentation. So we're going to try and keep things really general and address all the different types of things that you may find in your system. And hopefully that will help you familiarize yourself with your irrigation system, and that everybody in attendance will be able to find useful information and the best measures that you can take to winterize your specific system. As Andrea mentioned, we want to really encourage you to type in any questions that you have that we can address at the end of the presentation. And if for some reason we don't get to your questions today, or we don't answer it sufficiently, make sure and get our contact information, follow up with us afterwards, and we'll be happy to make sure we do everything we can to get you pointed in the right direction. So before we get started, there are some tools that may be helpful in your winterizing adventures. Frankly, a flathead screwdriver is often, the only thing you really need to make sure that you get the key things done that we're going to talk about today. Flathead screwdriver basically is going to help you make some adjustments that Cal will talk about a little more specifically in the presentation. The next thing that might come in handy would be just a small hand spade, a tiny little shovel, if you will. And that can be helpful for cleaning out some of the valve boxes that you may encounter, to make sure that you have access to the different assemblies and devices that we'll be addressing as well. Some of these components tend to be, or most of these components tend to be underground these days. And as such, they're vulnerable to incursions by, backyard critters like moles specifically, that can get into valve boxes and fill them up with dirt. So a hand spade can come in handy to help clean things up and provide you with good access to the components that we're going to talk about. A valve key, and we'll show you specifically what that is later in the presentation, is helpful for opening and closing valves that are located subgrade. Because we're talking about looking at components that are typically in valve boxes, again, subgrade, a flashlight can come in handy. And if you're like me and you find yourself continuing to get older, knee padding will come in handy as you kind of get down there and try and get into these valve boxes and assess these different components and get them prepared for winter. So those are just some tools that can help you get the task done that we're going to talk about today. So the first thing we want to do when we're looking at winterizing our systems is figure out how to shut off the irrigation water supply and to get that done. And typically you're going to locate a shutoff valve installed in between the water meter and the backflow device or assembly. And generally that's going to be located in a valve box similar to the image that you see on the left. Oftentimes they're in a round valve box with the green lid, and keep in mind that those boxes are subgrade, so all you're really going to see is that green top. Sometimes they're square, sometimes it could be a 6-inch box, it can be around a 9-inch box or even larger. But that's really the typical place you're going to find an isolation valve if you have one. You may not always have one, but that's what you're looking for. And then inside, you're generally going to find a valve like the two images that you see on the right, either a gate valve with a round handle, or you'll see a ball valve with more of a lever type handle. And the gate valve is just, it's kind of the traditional operation of righty-tighty, lefty-loosey. You turn it to the right to close it down, you turn it to the left to open it back up. And so you just want to, in this case, shutting off that valve, turn it to the right as far as it will go. And the nice thing about a ball valve, or the valve that you see on the right, is that that lever actually gives you a good visual indicator as to the status of the valve. When the handle is parallel to the valve and the pipe, that means that the valve itself is open and that the line is under pressure. If the handle is perpendicular to the body of the valve or the pipe, that lets you know that you've got things closed all the way. Sometimes the shutoff valves and drain valves, for that matter, are going to be, and we'll talk about drain valves later on in a few slides, but sometimes the shutoff valves are actually incorporated into the same valve box as a backflow assembly. So again, you're going to need to do some homework to kind of assess your system to learn where these different components are. And in this image, we see a picture of a backflow device, a double check assembly, I should say. And in that same box, they've installed an isolation or a shutoff valve, and that's the valve that you see up at the top of the image that is the gate type valve with the round handle. So if you don't have a standalone shutoff or isolation valve, you can actually use the upstream ball valve on the pressure vacuum breaker or a double check valve backflow assembly to essentially act as a shutoff valve to close off the water supply from the backflow assembly and the irrigation main line. It's not an ideal situation, but I've encountered it more times than, well, quite often. Again, there's not a lot of standardization with irrigation systems, so you really just have to assess your system, and you may have different limitations, but there's ways that you can adapt and still provide a degree of winterization to avoid any damage. So if we can get my cursor here, looking at this double check assembly, you can see there's actually two valves on either end, and there's actually an arrow here that's indicating the direction of flow. So as I mentioned, the upstream ball valve, that would be this one. So water's flowing this way. This is the upstream ball valve. You would simply turn this handle so that it's perpendicular to the pipe. So turn it to the right, and that effectively is then going to shut off the supply of water to the backflow device and the rest of the main line to your irrigation, and effectively will depressurize that. The next step is going to be to investigate and locate any manual drain valves that might be present on your system. And typically, a drain valve, if installed, is going to be located with a valve manifold at the end of the main irrigation supply line, at a low point in the main line, or near the backflow assembly, again, similar to the isolation valve. And what you're looking for are valves that look similar to the two images in the center of the slide here. And if they're at the end of the line, as we see in the image to the left, it's incorporated at the very terminal end of our main line, and it's just included what this is called is a valve manifold. And these are the electric valves that operate individual zones, and these will be located in a square or rectangular valve box, again with that green lid. And this is a very common place for drain valves to be installed. And you can see that that boiler valve drain type of a drain valve installed at the top of the image, again at the end of the drain valve, at the end of the valve manifold. And so once we've got our main line shut off, you can slowly open that drain valve to allow that main line to then passively drain out. And a valve key can be really handy in this situation, particularly if it's installed subgrade. And that's what we see over on the right. That's a valve key, and those are really designed, especially if your drain valve is this type here, the second from the left. This sort of a cross type handle can be really difficult to operate with your hands. So a valve key is really kind of crucial for this type of a valve, but they're very common in terms of being used for drain valves. So you may want to invest in one of these keys, and you can generally pick these up for $7 or $8 at your local hardware store. Pretty easy to find. The next step, if possible, is to then go back and assess if it's possible to drain the water in between the isolation valve and the backflow device. And we've got a bit of a little schematic here on the right that is sort of the image of an ideal irrigation system, sort of the anatomy of an irrigation system, if you will. And it's just kind of helpful to help you conceptualize, you know, how these components might be laid out to help you assess your system and figure out where these different devices may be. Here you see the main domestic water meter, and then shortly thereafter there's a T where begins the irrigation water service. So in between your meter and a backflow device is typically where you're going to find some sort of a shutoff or an isolation valve. And then shortly downstream, hopefully you're going to find a backflow prevention assembly. In this case, in the image, this is depicted as above ground, and in most cases, we're actually going to be again in a valve box. But what we're looking at here is the ability can we drain the water between the backflow device and the isolation valve? And what we're going to look for is on the isolation valve itself, we want to look and see if you have a drain cap similar to what we see here in the image. And some gate valves and ball valves, both of those types have this type of a drain cap, and it's just a nice feature that will allow you to kind of open that up again once that valve is closed, and that will let you drain the water that exists between the isolation valve and the backflow device. And hopefully these devices were installed properly, and the drain cap is indeed between the pressurized main service and the device. I've actually seen this installed where unfortunately the drain cap is on the other side, and so when you go to drain it, it remains under pressure and you get a nice blast of water in the face. So we're really hoping things are installed properly and you have the ability to drain as much as possible between the isolation valve and the backflow device. And here's just a nicer image again of the sort of the anatomy of an ideal irrigation system. Again, you've got your domestic meter, isolation valves, the main line going into the residence, some type of a backflow prevention device, pressure regulators, master valve if you have one, and then the continuation of your main line out to the manifolds or the individual electric valves that control the operation of your lateral lines or each of the individual zones. And again, these manifold boxes are where you're likely to find drain valves. And so just keep that in mind as you're assessing your system and searching for the various components that you have that will give you the ability to winterize your system most effectively. And now I'm actually going to turn it over to Cal, our resident expert on backflow prevention, to talk a little bit more about the specific devices that you may encounter. Cal, you there? Can you take it away?
Yes, thank you, Steve. I'm just going to jump right on in here. There's actually up to 5 different types of backflow preventers that you can see on your underground sprinkler system. However, in Oregon, and specifically here in the district, these are the most common types here. The double check here on the left, which is by far the most common. The middle, which is the pressure vacuum breaker assembly. And then on the right is an atmospheric vacuum breaker. The double check is usually installed in the ground prior to the solenoid zones, housed in a plastic irrigation box with a green access lid. The pressure vacuum breaker is also prior to the zones, but is always above grade for its installation, because to properly prevent backflow, it has to be installed 12 inches above all of the downstream piping. So in this case, it would be the sprinkler heads. The atmospheric vacuum breaker, similar to the pressure vacuum breaker, will also be above grade. However, it's required to have the atmospheric vacuum breaker after the solenoids. So this results in having multiple atmospheric vacuum breakers to an irrigation system. These atmospheric vacuum breakers, they could be insulated for the winter, but are a bit more difficult to properly drain since they are non-testable devices that don't have test ports or shutoff valves located on them. The double check and the pressure vacuum breaker are assemblies which do require annual testing. Therefore, they do have shutoff valves and test ports on the assembly. So this will be helpful to us when we discuss here draining the assembly. The shutoff valves and test ports are almost always ball valve type of valves, which when closed, it traps water within the valve and the assembly. So when the trapped water freezes, the shutoffs, test ports, and the assembly can break. To prevent this, it's crucial to close the irrigation main isolation valve located prior to the assembly, open the shutoff valves and test ports 1/8 of a turn, which is approximately halfway open, or at a 45-degree angle to drain the assembly. On the assembly shutoff valves are typically hand operated if they're in decent condition. However, the test ports require a flathead screwdriver like Steve had mentioned. On the next slide, I'll show you an example of a double check with the valves turned properly. Next slide. Thanks, Steve. So here the green handles are the shutoffs. When they are parallel with the backflow assembly, it means they are fully open. When they are perpendicular, it means they are fully closed. And similar with the test ports, when the screwdriver slot that you can see there is parallel with the test port, they are fully open. And when perpendicular to the test port, they're fully closed. So you can see in this picture here that they're all about halfway opened at that 45-degree angle. And this allows some of the water to drain, but most important, it allows for the expansion to occur when the water freezes. The idea with water is it's not compressible, so when it freezes and it expands, if that doesn't have anywhere to go, it's going to break whatever is trapped in. Quick disclaimer that after you have these valves all open for the winter, next season when you go to energize your system, you want to make sure you go back and reclose the test ports. Because as you would imagine, if you open your isolation valve with those open, you'll have a rude awakening of getting soaked down by those ports. Next slide, please. So here's a common yet a severe consequence of allowing a closed ball valve to freeze. When the water freezes that is trapped in the internal ball of the valve, since water, like I said, is not compressible, it's going to find the weak point in that valve, and like you see here, it ends up pushing its way out the side wall of the valve. This is really common, and so that's why it's so important to make sure that you open the valves to allow that water to drain out. If you have any more questions backflow related, please write your questions down and ask them at the end, and I'm more than happy to answer those. Back over to you, Steve.
Thanks, Cal. And as Cal mentioned, please do remember to type in questions that you've got in the chat, and we will make sure and get those addressed as best we can at the end of the presentation. The next step that you can take, and this is optional, some folks in the last few years have taken a step for water efficiency and have installed sprinkler bodies that actually have check valves in them to prevent what we call low head drainage, or after each cycle, it prevents water from passively draining out, which we love from a conservation standpoint, because that water then can be used on the next cycle to provide irrigation to the plants, which is the whole point of having an irrigation system. However, when we talk about winterizing, that creates a little bit of an issue or a challenge with draining the lateral lines in between the electric control valves and the terminal sprinklers. But the solution is pretty simple. All you really need to do is go to the lowest sprinkler head on each zone, and either, with your fingernails generally is easy, or use a little small flathead screwdriver, basically to get under the rim of the nozzle and extend the pop-up body all the way, and just do it gently and keep it, don't torque it side to side, but straight up, and that will deactivate the check valve and allow water to passively drain out the body of the sprinkler. And the most common type of sprinklers are on Rainbird sprinkler bodies. It's easily identifiable by that SAM stamped into the sprinkler cap, which stands for Seal-O-Matic. So if you have that type of a sprinkler body, that's how you address that check valve conservation measure. And if you're not sure, you can take a photo of the sprinklers that you have and then go online and look up according to the manufacturer you have, and you can generally pretty quickly diagnose whether or not you have that functionality in your sprinklers. Or the other way is to just observe them, and if you see water typically flowing out from the top of the lowest sprinkler heads at the end of each cycle run, then you don't have check valves in your sprinkler bodies. The next step is to now go back and actually close up all the manual drain valves and caps. So you basically just go back to the location where we've located these devices, make sure you've got those valves reclosed nice and tight. And again, if we've located any drain caps on the side of those, make sure that those are tightened up again, because we don't want to lose that cap. Or as Cal indicated, we don't want to repressurize the system and have that blow out and create a leak and a mess in your nice cleaned out valve box. So just make sure you've got your manual drains and any caps closed back up nice and tight once you've got things drained out to the best of your ability. The next step is to go to the irrigation controller itself and turn the dial in most cases to the off setting, or however your controller is operated. Just make sure that it's in the off position for the season, and we want to leave the dial off, but we want to go ahead and leave the device plugged in, particularly if you have an outdoor mounted controller, and the heat from the transformer will actually help keep the enclosure warm enough to prevent any condensation from forming inside there, and that can prevent any damage over time. Leaving the dial in the off position will also keep the controller from activating the solenoids on individual zones over the course of the winter, which will prevent just any unnecessary wear and tear on those devices. And then lastly, it's a good idea to leave yourself a little note on the controller to make sure next year you're going to go back and close all the test cocks and the ball valves on your backflow device or assembly before you pressurize the system next spring. Don't ask me how I know that, but you want to avoid again getting a blast of water in the face, or filling your valve box full of water and just making things a little more challenging than they need to be the following spring. So a little reminder note on the controller is a great way to avoid that. And then finally, as we mentioned earlier, as Cal was talking about with pressure vacuum breakers and atmospheric vacuum breakers, those devices are installed above grade. And so there's always a few feet of exposed piping associated with those types of assemblies or devices. And so you just really want to take the step of making sure that any exposed piping is insulated. And it's just a simple thing to do. Go down again to your home improvement store and pick up some split foam insulation, and just get the right size for the diameter of pipe that you have. In most cases for these types, it's going to be either 3/4 inch or 1 inch. And you basically can just put that split foam around the piping and then wrap that with duct tape, and that's going to provide you a much higher degree of protection than having that pipe simply exposed. And then the other steps that we mentioned in terms of turning the ball valves and the test cocks 1/8 of a turn so that they're open, that's just going to provide you a really high degree of protection over the winter. If you happen to have rain sensors and weather stations, there's really not much that you need to do or really can do in order to prepare these devices for winter. Ideally, you've got them installed in a place that they're not going to be vulnerable to accumulating a lot of debris from trees, because we typically want them out in a highly exposed area. But one thing you can do if you happen to have sort of a larger catchment device similar to the image on the right is perhaps take a plastic bag or a piece of a plastic bag and cover that up on a warm fall day when we don't have a lot of water accumulated in there, and then sort of secure that with a zip tie. And that can help you prevent any accumulation of water or tree debris over the winter months that could possibly damage that or impact the performance over time. But that's really all you can do. And in most cases, I think folks really just kind of let them be, and we haven't seen a lot of issues with those devices associated with winter freeze damage in our area. Finally, we just want to make sure that you're aware of the high efficiency incentives that we have available to you at the Water District. If you've been considering upgrading your controller, or you're not sure how to really optimize your scheduling, upgrading to a WaterSense labeled weather-based irrigation controller is a really great opportunity when coupled with the $50 rebate available from TVWD. We also have $3 rebates per nozzle for what are called multi-stream rotating nozzles. They're a great way to really upgrade the water application to your landscape. If either of those are of interest to you, please feel free to check out our website, our rebate page for more information, and or contact me directly. Happy to provide any additional information or answer any questions that you may have about those opportunities for you. And with that, that concludes our presentation for today, and we'll be happy to open up our conversation to take any questions that you may have.
All right, Steve, thanks so much for that. And sorry for the delay. My computer froze for just a split second on me, but we have a lot of action in the Q&A today. So Steve and Cal, don't go too far away, and I wouldn't even bother muting those microphones for today. We're going to start with our first question is from a customer who writes, what is the backflow test on our irrigation system? Can I do it myself and not pay the annual check fee? And start with you, Cal.
Yeah, great question. So it's the backflow assemblies, they're required to be tested by a state certified backflow tester. So that state tester goes through a course to get certified that allows them to test and troubleshoot the backflow preventers. And so it's not something you can do yourself unless you went through that certification course. It's a short one, so if you wanted to test your own, it's a week-long course that you can get certified. But it is a test required to be done by a certified tester. And you can, there's two ways in our district to go about doing this test residentially. One is hiring your own certified tester, and we can provide you with a state website that will give you a whole list of testers, or asking a neighbor for a tester they may use. Another option, if your assembly is accessible, so not in a garage, but if it's outdoors, maybe behind a gate, we have a gold plan program, which we would charge you a subscription on your water bill of $35 once a year, and then we send our contracted testers out to perform the testing. So those are the two options for the testing. Was there a second part to that question, Justin?
No, not yet. We will get to more though. The next one is just a comment. It says, thanks for setting this up. Easy to join. Looking forward to the info. So we appreciate that. And we appreciate any feedback from our customers on how these events are going and what kind of content you like to hear. Next is going to be a question, or the next is also a question I can answer about making the slides available after the presentation. Yes, we will do that. These videos are recorded. We'll post them up to our YouTube channel and make all the content available on our website. So once we get all of that, we will post it. And there is a link in the chat from Andrea. Essentially, it is tvwd.org/talkinwater, TALKIN water. And that's the short link to get all of the past videos of these events. Next one is going to be likely a combination of Steve and Cal. We will start with you, Steve. It says, I have 2 sets of valve manifolds, front and backyard. My drain valve is only installed on the backyard set. Is that enough, or do I need to drain the front yard manifold too?
No, I would say that that's adequate. You know, you like I say, you work with what you've got. And, you know, I would say just, you know, count yourself as fortunate that you do actually have a drain installed on the main line, and anything that you've got downstream of that backflow is really going to be helpful. And again, in our area, things are so temperate that just providing a degree of passive draining is really going to provide you most likely with the adequate protection.
Awesome. Next one, staying on the topic, is how do we shut off irrigation for electric rainbird system? Is shutting off the rainbird system enough?
Well, if I understand correctly, I think they're asking is basically just turning off the controller adequate? And the short answer is no. I mean, that will prevent your system from operating, but you're not relieving any of the water pressure on the main line. And that's really what we're after here, particularly if you have an exposed pressure vacuum breaker or atmospheric vacuum breaker, you're still going to have water going up to that point. So again, ideally, you're going to want to go out and find out if you have an isolation valve that will allow you to turn off the water in between where the takeoff from your main service line to your house to the irrigation system. And then again, if you can take this, you know, some of the steps that we've laid out for you here today, you know, if it's a situation where you have atmospheric vacuum breakers, you know, there's not much more than that you can really do. You just, you know, you don't have, as Cal indicated, the ability to manipulate ball valves and test cocks. So really all you can do is turn off an isolation valve, and perhaps you have the drain cap on that valve that will allow you to sort of passively drain that main line. But again, you sort of need to assess the ability that you have with your actual piping, and then do the best you can to, like I said, take advantage of the steps that we provided today to provide some protection. But simply turning off the controller is not going to do any sort of hydraulic protection from freeze damage.
Awesome. And we'll stick with you again, Steve. Customer writes in, does your office provide recommended area companies that could help us with leak repair?
No, as a public agency, we can't really endorse private entities, but what I will say is if you're going to be having any type of irrigation work, whether it's testing, repair, design, installation, please use licensed, bonded, and insured contractor for that type of work.
And next up, question is it typical to have more than one drain valve in an irrigation system?
I'll say no. You know, again, I say count yourself fortunate if you have one. You know, again, it's really hard to say. Some folks, you know, fortunately would have something taken to the nth degree, and there's a drain located on every manifold. But you know, it's one of those things that unfortunately typically is a cost thing, and it's fairly rare that you have that. So if you have one, count yourself as fortunate. If you've got one at every terminal end of a main line, that's even better. But it's not common to have them in each valve box.
And when is a good time to drain the irrigation system? I am new to Portland, and welcome to Portland, Steve. What's your thoughts on it?
Yeah, welcome. Well, you know, it changes year to year. This year, you know, gosh, we've been done irrigating for darn near a month now, and there's years where we irrigate, into mid-October, but typically at some point in October, sometimes a little bit earlier, depending on when the effective rainfalls come in, irrigation season, ends. The nice thing is we've got a bit of a buffer generally between when supplemental irrigation is needed and before any sort of risk of a hard frost comes on board. So I would say your ideal window for doing this type of activity is going to be mid-October to mid-November before it gets really cold. Definitely want to make sure you've got this work done, I'd say before December 1st, and then through the winter. But again, when irrigation season ends really varies, and it seems to be pushing a little bit later and later the last few years. But I'd say, again, mid-October, mid-November is sort of the sweet spot.
Awesome. And Steve, we'll finally let you get a break for a sip of water. Cal, you are up for the next few. Customer writes in, why are you closing backflow partially?
Yes, so the idea between, or the idea of closing them, opening them not fully, is so the valve is going to be positioned in a way where water can drain out from all parts of the valve. So if you open the valve completely, you'll likely be okay. There's not going to typically be something catastrophic with that, but the potential is if water gets on the outside of the ball of the valve and gets trapped in the fully open position, it could lead to some damage. So to caution on the side of error, you want to have it partially open. If you open it fully, it's not going to typically result in more damage, but you'll have a slight increased potential of that.
Awesome. Thank you, Cal. And we're going to keep it rolling with you. So question is, just double checking. You keep the isolation valves closed and the valves on the backflow test ports partially open all through the winter until spring, summer, when you want to begin irrigation again.
So yeah, that's correct. So by having that isolation valve off, it's of course keeping water off to the entirety of the system. And then the valves open on the backflow assembly as a precaution to, if freezing temperatures are reached and that assembly were to freeze, there would be no water trapped anywhere that is going to cause a valve to break. And the main thing, sometimes we picture like, okay, I got to get every drop of water out of my system. But the idea is we want to make sure specifically that water is not trapped anywhere. Because what causes the freeze damage is when that expansion occurs, when the water freezes, if it can't expand anywhere, it's going to break whatever it is being trapped in. So that's the more important thing than evacuating all of the water.
Awesome. And we've got the next two are a little repetitive, but we can hit the comment again there from you, Cal. Question is, why not leave it open in the winter, referring to the backflow, and follow up to that is why only close the valve 45 degrees and not fully? Thank you.
So I think I kind of answered the not opening them fully in the previous one, of just in that position of the valve internally allows the water to not be trapped anywhere. And then can you remind me the first part of the question, Justin?
It was leaving them fully open throughout the winter.
Yeah, and that's just so, as of course temperatures fluctuate every time we hit that freezing temperature, it's going to remain in those valve positions, so no damage can occur within the backflow assembly.
Awesome. Next one is going to be for Steve. Do you recommend blowing out your system with an air compressor, or can that damage components?
We were waiting for that one. So in our area, in most cases, as Cal and I were talking about and preparing for this, is no, we don't really recommend it, particularly from a homeowner's DIY perspective. That's really something that you should do professionally. But again, in the Willamette Valley, things are so temperate that you really don't need to go to that degree. As Cal just mentioned, we're not as concerned about evacuating water from the entirety of the system as we are eliminating it from areas where it might get trapped. And as long as we're doing some passive drainage and creating some bit of opportunity for water, freezing water, ice to flow, that's going to in most cases prevent any potential damage. And then the other thing, and I'll let Cal expand on this too, is that we really, in many cases in our area, it's very rare that you see the proper sort of components installed on an irrigation system to blow out using pressurized blowout properly. It's pretty risky, and we don't want folks tying into the backflow assemblies in order to do that. And Cal, do you want to expand on that a little bit?
Yeah, definitely. So with blowing out irrigation systems, like Steve said, typically you want to have that done through a licensed contractor who's familiar with that, because the irrigation system should be designed to have a port specifically for hooking up an air compressor, which is downstream of the backflow preventer. When customers or even contractors at time attempt to hook up to the backflow assembly ports, that can lead to two things. One, and more severe, being a backflow incident. So hooking up to the wrong ports can actually push air back into your home's plumbing and our distribution system. And so that can cause aerated water to come out of your faucets, and it might scare you, and that could lead to much more severe things if it pushes anything like contamination back with it. So that's the most important thing to make sure that doesn't occur when using the air compressor, which is why we do not hook them to the backflow assembly. And this secondary is, if we blow air through the backflow assembly, air flows different than water through a backflow assembly, and it can actually cause a chattering of the check valves and can cause the components to break. And so that's kind of the answer to that. If you have a specific port for the air compressor on the downstream side of the backflow assembly, you can look into it farther, but please don't hook your air compressor to the backflow assembly because of those few issues that I brought up.
All right, we're going to go back to Steve again. Customer writes in, also, is it appropriate to leave the drains open throughout the winter once they've been drained?
I typically do not. I don't think it's necessarily going to hurt anything. I think the reason we want to close that is just to prevent, really any insects or from getting in there. Or the other thing to keep in mind is that, because these are typically subgrade, and once the winter months settle in, along with our typical weather pattern, if you have valve boxes that fill with water, then you're going to have some incursion into your system that can then also be accompanied by debris. So I think best practice is to, once again they've passively drained out as much as possible, go ahead and close them down, and you're just going to make sure that drain port stays nice and clean, and you're not getting any sort of contamination or obstruction in there.
Great. And Steve, will stay with you. Customer writes in, when I bought my house, the previous owner had paid for winterizing service that blows air through the irrigation lines to clear them. I haven't had that done since. How important is it for our area?
Like we've said a few times, it's really, I think, a bit excessive for our area. If you lived on the other side of the Cascades, or basically anywhere farther east than that, it becomes a little more of an issue, where you tend to have deeper, harder frost, and we just don't get that kind of a deep freeze around here generally. So in most cases, I think, again, the manual passive draining approach, and then again adequate adjustment to any backflow prevention assembly is most cases more than adequate for the Willamette Valley.
Great. And Cal, back to you with the backflow question. This one is, my backflow device looks like the first one on the left. It has multiple things that look like check ports. Do I need to open one or all of them?
Great question. So it would be all of them. Now, internal to the backflow assembly, each port is in a different pressure zone of the assembly. So if you only open up a few of them and not all of them, you won't really pressure from all compartments, I guess would be a way to explain it in the backflow assembly. Now, if your system does not have an isolation or an irrigation isolation valve, and you have to use the backflow preventer shutoff as the main shutoff, there is 4 ports, and there's one of them that you will notice is on the outside of a shutoff valve. So in the scenario that you do have to use your backflow assembly as the main shutoff, that would be the one that remains closed, because that is on the side to where there would still be pressure. But if you have an isolation valve, all 4 ports would be in that open position or in that 45-degree angle, so mostly open.
And Cal, I went ahead and adjusted the slideshow back to the image of the double check device there to perhaps we can point to the port that you're speaking to.
Yep, so on this one that we're looking at, the water flows left to right. And so your isolation valve would be on the left-hand side. Your irrigation isolation valve would be, off the screen to the left, that serves into that backflow preventer. So if you have that isolation valve closed, that'll allow you to open up all 4 of your ports, as well as leaving your 2 shutoff valves mostly open. And then, as I was saying, if you're using your backflow preventer as the main isolation, you would leave that one on the left closed completely, because that would be your isolation at that point to your irrigation system. The port that is all the way to the left, the test port that is on the outside of the shutoff, that would have to remain closed, unfortunately, or water would continuously flow out of there. But then all the other 3 ports would be able to remain at that 45-degree turn.
Awesome, thank you, Cal. And we got the next one for you still. Question is, if I'm set up with an automatic semi-annual backflow test service, spring and autumn, are they turning the system on and off when they complete the check?
Yes, so when the backflow tester comes out, they actually have to operate both of those shutoff valves, and they'll be closed for several minutes. So it does temporarily shut water off to the system. And normally a backflow tester, they're not going to shut it off while water is flowing downstream. They might, come at a time of day where it's not running. That's something you confirm with them. But it will be shut off depending upon the condition of your assembly. Some testers can test them in a couple minutes if all the valves are easy to operate. Some of the assemblies that get buried and shutoff valves start to break apart, where you have to use wrenches and things like this, it can cause the water to be off for, let's say, a maximum of 10 minutes for a backflow test.
Thanks, Cal. And going back to you, Steve, does TVWD have any incentives for those of us considering removing our lawns?
No, at this point, that is not one of our water efficiency rebate incentives. I always like to say that I'm not anti-turf by any means. We just like to get folks to think about functional turf. Whatever that function may be, make sure it has some value to you. And if there are areas that are struggling and you're trying to keep them alive and it's not working and you're putting a lot more energy into it than you're getting out of it, then that should be a great incentive to go ahead and make a change to something that also may be a little more less water and fertilizer and just general maintenance intensive. But no, we do not have incentives to financially encourage you to do that.
Thanks, Steve. We have another question about the recording of the presentation. So as a reminder, this is recorded. It'll be posted on the district's YouTube channel and as well at tvwd.org/talkinwater, TALKIN water. We'll probably have that up there later this afternoon or no later than tomorrow morning. And we have another comment. Thanks for having this informative presentation and meeting. It's very helpful. Well, we appreciate that. Thanks so much for the feedback. And question for Cal, how do we sign up for the subscription backflow testing service?
Great question. So if you go to our website, there'll be, as of now, an application that can be downloaded and then scanned and emailed to backflow@tvwd.org. If somebody had, I hesitate to say this with 60 people attending at the moment, but it would be an okay option as well. If somebody were to call in, we can take a verbal opt-in over the phone as long as your name is on the account. We can opt you in over the phone that way. Now, coming soon, so pay attention to our website as far as it'll be clear when this is available, but we are going to be having these applications having the ability to be submitted online. So rather than printing something and mailing it, or downloading a PDF, filling it out, and then emailing it, it would all be done through the web portal. So we're not there as yet. So stay tuned for that. If you're wanting to sign up right now, you can do it in the current process. But you will be reminded in February. So in February of 2022, we'll mail out our reminders, and in there we'll have the link to our website reminding you of how to sign up for the Gold Plan program to be included in that for 2022. And Gold Plan customers who are already in the Gold Plan by February receive a postcard that simply reminds you that you are in the Gold Plan program, and that we'll be applying that subscription to the water bill in the next month of that, so by March. And then the testing completed between March and September of that year.
Great, thanks, Cal. Steve, we got a couple lined up here for you. The next one, or I should say the first one for you right now, is what is an isolation valve?
An isolation valve, and let me see if we can go back to another image here just to show it to you, is basically a valve that allows you to close off the flow of water. And generally, you usually have a main isolation valve that turns off the flow of water to the irrigation system in general, hopefully. And it pictured here. So on the left is a typical gate valve. And, hopefully you have at least one in between. Let me get my cursor up here. Again, the T that connects the irrigation system to the main line or the main service into the home. And that isolates the irrigation system from your domestic service. And then in some cases, if, in an ideal situation, there are isolation valves located throughout the system on main lines, and that is not always the case. But again, it's just another valve similar to this that allows you to isolate various zones on the system from other zones on the system. And that can be really helpful when and if you happen to need to diagnose leaks at some point during the season. You're able to, again, isolate various portions of the system while other portions remain active. So if you do have damage and you don't want certain parts of the system to operate, you can isolate that, leave it off, while the other portions of the system remain functional. But they're just valves that are designed, again, to isolate the flow of water to a specific area.
Fantastic. And here we go with another one. When I tried to turn off the valve in the outdoor green box for irrigation, it didn't work. Like, I couldn't turn 90 degrees to perpendicular. Any recommended tools?
Boy, well, if you have DIY plumbing instincts, then it sounds like you need to replace that valve, which is going to involve, cutting the pipe upstream and doing some more involved repair. Or if that's not something that you're comfortable with, again, reaching out to a licensed, bonded, insured irrigation contractor to install a new valve for you so that you do have that functionality. It's, unfortunately, depending on older systems, and this is another reason why it's a good idea when you're doing that springtime assessment to have your handy hand trowel to make sure that those valve boxes stay nice and clean. because the more that you have soil incursion, submersion, the faster that these devices are going to corrode and degrade over time and lose their functionality. So it's really a good idea to just make sure, at least on an annual basis, that you're keeping them as clean as possible to maintain their longest functional life.
That's great. And the next one for you again, Steve. If my system doesn't have a drain valve, then is draining the test valve on backflow device acceptable?
Yeah, and so again, you got the right idea. You're kind of, you're looking for those opportunities, and if you don't find them, then you kind of take the next best option, which is going to be to, again, make sure that those ball valves and test ports on the backflow assembly are open, and that's going to prevent any water from getting trapped in that device, which is really the crucial point that we're worried about. And as Cal mentioned, we're gonna avoid trapping any water in there that's going to damage that most expensive component. And then the other nice thing is that when you open up, excuse me, the valves on the device, you're basically going to be relieving the vacuum on most of the rest of the system. That should also then encourage more passive drainage to occur down through the main line and the lateral lines as well.
That is great. And we've got a comment from the next customer. Would you please make a step-by-step YouTube video on how to winterize the irrigation system? Thanks. Thanks for the idea and the feedback. And it's definitely a good thing to consider. Steve, we're going to keep with you for the next one. Is it necessary to cover up the water outlets during winter? We have 2 of them, front and back, and pipes attached.
So I think they're talking about the spigots attached to the house, and yes, it is important. That's something that is probably going to show up on my honey-do list here in the next few weeks, is to go around and turn off the supply valves that are very similar to our shutoff valves here. I've got one under the kitchen sink and another one out in the garage that feed our spigots that pop outside of the walls that we run our hoses to during the summer months. So it's a very similar process. I'm going to turn off my shutoff valves on the inside in the garage and under the sink. I'm going to go outside and I'm going to open those spigots that are on the outside of the house. And then I'm going to go back. I actually do have the drain caps on my isolation valves too. So I'm going to carefully open that drain cap. And that again is going to relieve the vacuum and allow any water that's in that pipe in between the shutoff valve and the outside spigot to drain. Once that's drained off, I'm going to go back, retighten that cap, and then I'm also going to, just for extra safety measure, I'm going to put a styrofoam cover over the top of that spigot, just as an extra safety measure. If you don't have those internal isolation valves, at a minimum, you're going to want to make sure and pick up some of those foam covers for your outside spigots to protect them from freeze damage, because they are more susceptible to that, being that they are exposed as they are. And I believe we may still have those available for customers. Is that something you can check with Frank on?
We can check on that, Steve, and if we can get an answer quickly, we will post it in the chat.
Excellent.
All right.
And I love the suggestion for the how-to video.
Yeah, absolutely. So the next comment is crystal clear answers. Thanks for doing this. And another comment says, not a question, just a comment. Thanks. Very informative. And I appreciate your patience with the redundant questions and being so thorough. We really appreciate everyone spending the time with us today. And redundant questions is never a problem. We anticipate a lot of folks get the same question at the same time and everyone types it in. And that's just how these work. We enjoy answering all of them. And another question coming in here. Have you or will you do a Talkin' Water session on spring turn-on? Thanks. Steve, I know that's a good topic. Any thoughts on doing that one?
Sounds like we've got something in the works already. No, I think that's a great idea, and I would think that's something that we can certainly put together.
Awesome. And
I wanted to jump in quick. I'm sorry.
Yeah.
Just to clarify, I said earlier I just gave you the website, but to specifically get to the gold plan application, it's www.tvwd tvwd.org/gold-plan, and it takes you right to the page where you can have access to that application to submit. I just wanted to chime in with that real quick.
Awesome, thanks, Cal. Yep, tvwd.org/gold-plan. That's the redirect link, gets you right to where you need to go. And I'll go ahead and issue the last call for questions. We've just got one more comment, and it's a thank you. So we always appreciate those, but not seeing any new questions pop through the Q&A. So at that point, Andrea, I'll turn it back over to you.
Well, thank you, Justin, for moderating a really healthy Q&A session. Also, we want to thank you again for coming today and hanging in with us after the 1 o'clock. As part of this commitment, we want to stay on here until we've answered all your questions. And also, Cal, I owe you an apology for the really bumpy introduction. We just want to say how great it is to have you here at TVWD. He's our Senior Water Quality Inspector, and he came in September of 2020. And he's got a lot of experience, which I think you saw the depth of his knowledge today about cross-connection control and backflow, as well as other safety certifications. So we're really happy to have him part of the team, joining Steve in these efforts to help our customers have a better experience with their water system. So thanks, Cal, and thanks, Steve. And Carrie, I'll turn it to you to close.
I was just going to ask. Wrong thing. I was just going to ask if I can make one comment, and that is special thanks to our communication staff for putting together these series of Talkin Waters. This topic is always very popular and is well attended. Thank you so much for all your work, and thank you for the customers that joined in our Talking Water series, and we look forward to seeing you again next spring. Thanks, Andrea.